Good morning, everyone. This is Tomalimis over here. Welcome to the classes of education. I hope you have been watching the videos diligently and noting down whatever I have been teaching, revising it often because every class is interlinked with one another. As I will be teaching, you will find the relationship between the various concepts that has been taught beforehand and that will be taught in different classes. So, without delay of time, let's begin. But before that, let's take a road before delving deep into the details of today's topic. Let's recapitulate what has been done before. In the last class, we talked in details about volcanic eruption. And under volcanic eruption, we explored different types of landforms, be it intrusive landforms or be it extrusive volcanic landforms. Now, what is the next topic that is going to be explored in relation with this chapter of volcanic eruption? When volcano erupts, there is the concept of lava and magma, as the people are already acquainted with. Magma is the molten material in the interior of the earth, whereas lava is the molten material which solidifies on the or flows on the surface of the earth. Now, when it solidifies, it takes a certain structure. It forms a certain structure when it cools, because when something is in the interior of the earth, that is in a molten stage. And gradually, when it comes up because of several processes acting in the interior of the earth due to internal forces, when it comes up on the surface of the earth, it solidifies, or it rather faces a drop in temperature. That drop in temperature leads to the solidification of the lava on the surface of the earth, and that is in turn form rocks. It will get even more clearer as we go deeper into the details. So the session will be divided into two parts. The first session will try to explore what is the rocks, what are the different types of minerals, what are the different types of elements present on the earth's surface, as well as the texture of the minerals that is present in the rocks. And in the next session, I would explore the different types of rocks, primarily igneous, sedimentary, metamorphic, and rock cycle. So in the first session, let's begin. So let's begin with the topic minerals and rocks, which comes in NCERT class 11 book. This chapter, I think, is in number 4 or number 5, which is coming not just after the volcanic eruption, but after, I think, the oceans and continents. But I would like to teach you just after the volcanic eruption, because there is a very direct link, and we shall explore that link. And I shall justify that why have I picked up this topic and why not the topic of oceans and continents as given in the NCERT just after the volcanic eruption. Okay, before going deeper into the details, it becomes very important to know what is the concept of rock, what is the concept of mineral, what is the concept of elements. Remember one thing, a rock is an aggregate of mineral or togetherness of mineral. For example, let's consider one school. For example, St. Michael's School. St. Michael's School of certain place is a rock. Within the St. Michael's School, whatever classes are there, like pre-nursery, nursery, class 1, class 2, up till class 12, those are the minerals. And now, within the classes, for example, I am considering the students of class 11, they become the elements. So, can I say the class 11 students, the class in the elements, those are the class 11 students. Now, along the elements, they together form the minerals. That means there is a class 11 student, class 12 student, class 10 student, class 9 student. And then the minerals together, they form the rock. For example, the class 11 students, class 12 students, 9, 10, 8, 7, 6, 5, 4, 3, 2, 1 students, they form the basis, that is a St. Michael's School of a certain place. For example, I'm just randomly taking up the example. So in this case, how can we explain? A rock is an aggregate of minerals, right? And the elements are nothing but the part of the minerals. The elements are nothing but the part of the minerals. So let's break it up. For example, granite. A granite is a type of a rock. We shall explore that what is this granite. A granite is a type of a rock which is composed of several types of minerals. Several minerals. For example, in this particular diagram, it is written quartz, feldspar, biotite. These are the three types of minerals. Quartz has its own properties, which is different from that of feldspar. Feldspar has certain properties which is different from the properties of the biotite mineral. But these three minerals compose the composition of the rock. So a granite is nothing but the aggregate of the minerals or the togetherness of the minerals, right? And if I consider just one mineral, for example, quartz, within the quartz I will find certain elements, and those elements, for example, are silicates and oxygen. So when I am breaking, I get several parts. Rocks can be divided into minerals, minerals can be divided into elements. So that is what we are going to explore, that what are the different minerals and what are the different elements that are found on the surface of the earth. Please have a look into the first image. It is written the 8 most abundant minerals which constitute the earth's crust. Why am I talking about the earth's crust? Because after all, minerals are found in the rocks, and the rocks, when it solidifies, it is mostly, I'm saying mostly, it is found on the earth's crust. It can be also formed inside. That is not the problem, but whatever is available to us, on the basis of that, we can identify that these are the minerals. I'm not supposed to go into the interior of the earth and then identify what is directly available in front of me, that I'm easily like able to identify. So the minerals that constitute the earth's crust or the outer layer of the earth's surface, there are total 8. There are total 8 minerals, starting from oxygen to S. Now I shall let you know one trick which I did remember when I was preparing for the UGC NET JRF examination. How to remember the minerals in a descending order. For example, O stands for oxygen, S stands for silicon or silicate, A stands for aluminium. So I use the abbreviation. For example, I just took the letter O, then I took the letter S, then I took the letter A. So OSIC. O stands for oxygen, S stands for silicon. So I never really remembered the name of these minerals. I remembered the abbreviations like OSIC. And then I used to break it during my exam. Acha, O means oxygen, silicon means S means silicon. So that is how I remembered. Now, if you're asked the question that name the mineral which is found in abundance on the earth's crust, your answer should be oxygen. Again, if the question comes, name 2 minerals or name 2 minerals which constitute the earth's crust in huge abundance, that will be definitely oxygen and silicon. And you should also remember the percentages. That is very important. Now, if I break it up more, the most common minerals that are found all over the earth are somewhat different than the 8 most abundant minerals. Abundant minerals means found almost everywhere. Abundant, it is found in huge amount. But out of these, the most common minerals which are found all over the earth, that is somewhat different. So there is a basic difference between these 2 images. Now, if I break it up further, that out of the 12 most common minerals, which are the minerals which constitute about 93% of the mass of the earth. Now, out of the 100%, 93% of the mass of the earth is composed by these 4 minerals, primarily iron, followed by oxygen, then silicon and magnesium. So it might seem boring at the beginning, but whenever you write certain charts, not only for this, for the other chapters as well, try to write down the abbreviations and then remember the abbreviations. Other things will easily come to you. Now, it becomes very important to study the texture of minerals before we proceed on to the different explanation of the rocks. What is the texture? For example, the magma is trying to come up on the earth's surface, or whether it is trying to come up in the interior of the earth only. The rock will try to solidify, and as I told you, the rock is nothing but the aggregate of minerals. The minerals will try to arrange themselves in certain pattern. The minerals will try to arrange themselves in certain pattern, and that pattern will somewhat lead to what is called texture. So your texture is nothing but the arrangement of the crystals within the minerals which are found within the rocks. And it is on the basis of different textures we can identify different types of rocks. So always remember, texture is found in the crystals which are found in the minerals of the rocks. Okay, I shall draw it in the pen and I shall show you, but before, let's delve into the explanation part. Okay, please have a look into this diagram. First. Let's categorize that as A, B, C and D. Now, how can we classify certain textures? And there are certain names that are being assigned to the texture of different types of rocks. Now, remember one thing. Before I begin this, let's go back to another page. For example, this is the surface of the earth where one person is standing. And this is the interior of the earth. I'm writing magma chamber. I hope by now you people know that what is a magma chamber, where the magma is being produced in the interior of the earth owing to the high temperature. Now in the magma chamber, from the magma chamber, when the magma is trying to rise up, this is A point, this is B point, this is C point. Obviously the B point is having a lesser temperature than that of A, and the C point is having an even more lesser temperature than that of B and A, right? So can I say at the A there is highest temperature? Just give me some time. At the A there is highest temperature. At the B point, there is moderate temperature, and at the C point there is very low temperature. I'm writing low. Pardon my handwriting. At the C point there is very low temperature. So at the C point the rate of the cooling of the lava will be somewhat very different than whatever is trying to cool at the point A or at point B. Now this rate of cooling will determine what is the texture of the rock, or what is the arrangement of the crystals in the minerals which are found inside the rock. Now let's say for example at A, the one rock close to A, one rock is forming. I'm giving it a blue color. Close to A, one rock is forming. Close to B, another rock is forming, and close to C, another rock, one rock is forming. Now, how will I determine the texture of the rock? And that will be different at a different location. That is at A, B, and C. Now, at A, can I say the temperature is very high? Right? The temperature is very high, and the crystals within the minerals, they are trying to arrange themselves because they are getting a very high temperature. So they are very slowly solidifying because they are experiencing a very high temperature. So I am writing over here slow cooling. And at the C, there will be a very fast cooling. Why? Because C is the surface of the earth where the lava has just come up and the lava is trying to solidify. So the lava is seeing that अरे बाबा मैं तो बाहर आ गया, magma से बहुत दूर आ गया, मैं तो solidify कर जाऊंगा. So at the C, the rate of cooling or the rate of solidification of the lava will be very fast than what is solidifying at point A and B. So in A, I'm drawing the minerals crystals in green color. The mineral crystals are more or less very scattered in nature because they are not getting time to solidify. Let's consider that this is the size of the mineral crystals. What size, large or small, we will talk about that later on. Now consider the C. I will talk about B at some other point of time. At C, the mineral crystals are also within the rock. It is solidifying because the rock has come out on the lava has come out on the surface of the earth. So what happens when the crystals in the minerals, they are saying अरे बाप रे मैं तो बाहर आ गया, बहुत कम टेम्परेचर है, चलो जल्दी जल्दी सॉलिडिफाई करते हैं. उस जल्दी जल्दी के चक्कर में क्या होता है, द मिनरल्स दे बिकम वेरी क्रेजी. दे आर सेइंग अरे बाप रे इतना कम टेम्परेचर हो गया, अभी तो सॉलिडिफाई जमना तो बनता ही है. So the minerals, they in a haphazard motion, they move one against the another because they experience a sudden drop in the temperature because there is a fast rate of cooling or the fast rate of solidification of lava, for which the minerals, the crystals, while arranging themselves crazily and very hectically, they clash with one another. So when for example, ये मिनरल अगर इस मिनरल से क्लैश होता है, धक्का लगता है, तो धक्का लगने के बाद इसका साइज तो छोटा हो जाएगा, right? But in A point, what was happening? The minerals were just trying to solidify. धीरे धीरे वो solidify हो ही नहीं पा रहा है धीरे से, तो इसलिए scatter कर रहा है. लेकिन at C point the temperature इतना कम है कि minerals, they are becoming very crazy. They are saying अरे बाप रे क्या हो रहा है? तो they move here and there because they are willing to solidify very quickly. उस क्विकली के चक्कर में वो धक्का खाता है. There is a collision within the crystals of the minerals. When they collide, there is, due to the friction, the sides get eroded somewhat because of this collision, and the size of the crystals, they decrease. So at A point where there is a very high temperature, one gets large sized crystals. और मैंने वो क्रिस्टल ग्रीन कलर से किया है. And at C point, that is where there is a very where there is a very fast rate of cooling or very fast rate of solidification of lava, the minerals or the crystals within the minerals, they tend to collide, and after collision they become very small in size. So at C point you will find small sized crystals, and definitely at B point what will happen, A point से उसका crystal ज़्यादा छोटा होगा और C point से वो बड़ा होगा. So for example, the size of the crystals would be somewhat like this at B point. So please have a look at A point, B point, and this is a B point. A, B and C. So at A point, with the rocks which are solidifying, even if they are close to the magma chamber, they can solidify. That's not a trouble. Magma chamber के ऊपर तो solidify नहीं कर रहा है, उससे थोड़ा हट के solidify कर रहा है. तो वहां पे जो crystals form होगा वो सबसे बड़ा size का होगा. We have a name for it. I'll come to it later on. And then at the C point, that is the outermost layer of the earth, where the lava is solidifying, forming the rocks, because of the fast rate of cooling, it will give rise to small sized crystals. So the texture that I'm going to teach you with the help of an image is nothing but what is based on the rate of the solidification or the cooling of magma or lava. Okay, please have a look. Please have a look. This is A, this is B, this is C, and this is D. Please have a look at C and D. First have a look at C and D. C and D को देख के क्या पता चल रहा है कि अगर हम C रॉक को अपने हाथ में लेंगे, कुछ फील होगा, हम महसूस कर पाएंगे जब उसको हम हाथ में रखेंगे. मतलब बहुत एक रफनेस ज्यादा फील आएगा. Rough, we will feel a very rough texture, and this texture is happening because of the arrangement of the crystals of the minerals. Whereas if I hold the D rock, I won't feel that roughness of the surface. Whereas if I hold the C rock in my hand, I can feel the roughness of the surface. So why is the roughness more? Because I can tell with surety that at the C rock, what has happened? There must have been very slow solidification of the magma, for which the minerals did not get time to arrange itself properly, and thus the crystals become very large sized because of the slow rate of cooling of magma owing to high temperature. Whereas at D, if the D rock, if I'm holding it in my hand, I would feel a very smooth texture. वो खसखस वाला feeling नहीं आएगा हाथ में. Why? Because I will come to a conclusion that the D rock must have formed on the surface of the earth with a very low temperature, for which the minerals were able to properly arrange itself, for which the crystals became they moved very haphazardly owing to low temperature. They collided with one another, and upon collision the size decreased because of the friction. We have a name for it, for the textures. ये textures का नाम आपके NCERT के book में नहीं लिखा है, but I thought it's very crucial to understand this. Although if you are not a geography student, it's very important, and I should teach you this. So उस C texture का नाम है phaneritic texture. Phaneritic texture. I'll increase the font size. Phaneritic texture means rough texture. Rough. और आपके D point में जहां पे smooth feeling आ रहा है, because of the low temperature of the earth, and for which the rocks were able to solidify quickly, minerals were able to arrange very quickly, crystals collided with one another, and because of friction their size decreased. So we have a name for it. We call it aphanitic texture. And aphanitic texture, it gives a very smooth feeling. Now all this while I have been talking about the solidification of lava and magma giving rise to a type of a rock. So all these rocks, the images of all these rocks are nothing but what is coming out from the solidification of lava and magma, and those rocks which are formed from the solidification of either lava or magma are called igneous rocks. IGNEOUS, igneous rocks. So ये चारों rocks igneous rocks के examples है. चारों texture, ये जो images है ये texture का है, और ये texture is nothing but what is found in the igneous rocks. Okay, और igneous rocks के बारे में हम बहुत ज्यादा details दूसरे सेशन में करेंगे. ये सेशन सिर्फ फोकस करेगा what are rocks, minerals, textures in details, and the name of the textures of the different minerals. Now consider the A and the B one. A and B one. Out of A and B, where would you say the crystals are homogeneous in size? Homogeneous means एक समान है, equal in size. Or if I put the question differently, in which diagram out of A and B the crystals are of different size? Obviously, if I ask you the question where the crystals are of smaller size, you will opt for B, and where where they are homogeneous in size. B homogeneous means uniformly बड़ा भी हो सकता है, uniformly छोटा भी हो सकता है. So if I am talking about B, देखने से पता चलता है कि हर एक crystal uniformly छोटा है. But if I talk about A, then I can say there is a heterogeneous size of the crystals. अलग अलग है, कुछ छोटा है, कुछ बड़ा है. For example, B में हम देख लेते हैं. ये काला वाला मिनरल का टेक्सचर ये छोटे साइज का है, whereas ये सादा वाला भी छोटे साइज का है. अगेन ये ब्लैक वाला भी छोटे साइज का है. ये थोड़ा ये ब्लूइश कलर का भी मिनरल ये छोटा छोटा कलर का है टेक्सचर क्रिस्टल वाला. तो ये तो सेम साइज का हो गया और छोटा छोटा हो गया. तो इस छोटे का एक अलग नाम है. और because this is uniformly small and they are equal in size, the crystals are equal in size, so we call it a equigranular structure. Not structure, equigranular texture of the igneous rock. Whereas in point A, can I say that there are large crystals which are found within the mesh of the smaller crystals? ऐसा लग रहा है कि बड़ा बड़ा जो क्रिस्टल्स है वो छोटे छोटे क्रिस्टल के जाली में फंस गया है. आप वो पूछ सकते हो छोटा छोटा क्रिस्टल क्यों बड़ा बड़ा क्रिस्टल के जाली में नहीं फंसा है. फॉर एग्जाम्पल, जब हम लोग बिल्डिंग कंस्ट्रक्ट करते हैं, when we like construct a building, when we put the block of the block of brick, not rock, the block of brick, that is one big. And when we put two bricks together, how do we hold them together? Because of the cement that we put inside. Cement is not a very big size. The particles in the cement, they are very fine, very smooth. So the fine, smooth cement is holding the large sized bricks, right? Over here also the same thing is happening. The large sized crystals are caught up. They are caught up in a mesh of the small sized crystals. This texture, where the crystals are not of homogeneous size, be it either uniformly small or uniformly large, we call it a porphyritic texture of the rock. Porphyritic texture of the rock. So let's repeat once again. Out of A and B, in B, one can observe that the crystals are homogeneous in size. Because they are homogeneous in size, we call it an equigranular texture of the igneous rock. All right. Out of A, B, C, and D, in A, the large sized crystals are caught up in a mesh of small sized crystals. That particular texture, which is heterogeneous in nature, we call it a porphyritic texture of the igneous rock. Out of C and D, the C diagram is somewhat representing a very rough sized crystals, a very rough surface of the rock, depicting that the crystals are of larger size. Why? Because the rock of the C must have formed very close to the interior of the earth or close to the magma chamber, for which the rate of cooling is very slow. The rate of cooling is very slow, and the minerals did not get much time to arrange. The crystals also did not get much time to properly arrange, so they were scattered. That scatteredness led to the large sized crystals in a phaneritic textured rock, giving rise to the rough surface of the rock at point C. Point D is depicting a very smooth texture of the rock, smooth or the fine texture of the rock, because of the fact that the rocks are formed much away from the interior of the earth, primarily on the surface of the earth, where the temperature is very low in comparison to the interior of the earth, for which the rate of cooling is also very fast. The minerals are trying to arrange themselves very hectically. In the process, they collide, and that collision leads to friction, and because of the friction, their size decreases, giving rise to small sized crystals in aphanitic textured rock, which in turn gives rise to smooth surface of the rock. All right. And on the basis of this texture, I'm going to continue my lecture of the igneous rocks in details in the next session. All right. So thank you for now. I hope you have liked the lecture. Even if not, please let me know. I would require a frank judgment on this particular work of mine so that I can reach more and I can teach you people more nicely. All right. So let's meet in the next class. I shall continue with the rocks chapter, starting with the igneous rocks by taking the examples of this texture. That's it. Thank you very much. Have a nice day. Take care.